So to our question of how much work will it take to stretch that spring, what's the formula for work? Try to remember that. It is the force applied, which should be constant for that formula to do what we need it to do. So some constant force times the distance moved. But we can't just say some constant, whatever constant force for all 4 centimeters because it wasn't a constant force. So let's use our big idea of calculus. One of our big ideas, break things up into little sections where each section is roughly constant. So let's say for the first 0.1 centimeters, what's that constant force? Well, we're not moving very much, so even though the force is different at the start of the 0.1 centimeter and the end of the 0.1 centimeter, we could say it's approximately the same the whole time through. So we could say that the force is approximately 0.9217 or whatever it was, 9127 times 0.1 centimeters. That's the x here. Times how much did it move? Well, it moved 0.1 minus 0.0. How about the next 0.1 centimeters? The force is 0.9127 times 0.2 centimeters, because we're now 0.1 centimeters past the 0.1 centimeters we just were at, times 0.2 minus 0.1. And you can see where this is going, right? Just repeat it a lot. So if we say x is the amount of stretch, then each of these is an x value, and what do these look like? Basically delta x, right? And we shouldn't just work in 0.1 centimeter increments, we should work in 0.01 centimeter, or 0.001 centimeter, or 0.0001 centimeter. So instead of delta x, we'll write it as dx, because that's basically delta x where it's gone to an infinitesimally small amount. So we'll have 0.9127 times x is the amount of force we're applying for any particular amount of stretch, times how far we're moving with that constant amount of force, and then how do we add it all up? We take the integral, x equals 0 to 4 centimeters, and that will be the total work done to stretch the spring 4 centimeters. So our other question was, if I stretch it or compress it twice as much, does it take twice as much work? What do you think is going to happen here? So that would be from x equals 0 to x equals 8 centimeters, but still the same function inside. So will this integral be twice as much as that one? It's not going to be a hard integral, right? We're integrating x, we're going to get x squared. So when you're using x squared, if you double x, do you get twice the output, or do you get something else? So here's a really interesting way to think about this. Do you remember, maybe you've seen in statistics, something called standard deviation, which is kind of, it's hard for a lot of people to think about. It's kind of the average distance of points from the mean, where you like square stuff, then average it, and then square root it. In some sense, what standard deviation is doing is measuring how much energy it would take to stretch a spring from the mean to a data point, doing that for all the data points with equal strength springs, and then kind of averaging all that energy. So there's interesting links between all this spring energy stuff and standard deviation in statistics.